The students in kindergarten are continuing to explore with addition and subtraction within 10. One of the benchmarks that come up is this idea that every number from 1 to 9 has a pair that matches with that number, a number that we can add to that number to get to 10. Now, while I'm not going to talk necessarily about a strategy for figuring that out, I think this video has a lot of importance because this understanding of pairs to make 10 is a major piece of developing fluency later on in first grade and second grade as our ranges of numbers where we are adding and subtracting increase. Being able to very quickly, very efficiently, and accurately make 10, in which later on we'll become making other multiples of 10, is an important milestone in building that understanding and being able to reason about addition and subtraction. And so this one is a little different. It's not necessarily a specific arithmetic strategy, but it's a concept that's going to come up in a lot of strategies. So it's one that needs equal attention as we would give to any sort of arithmetic benchmark we have around the operations, is understanding those pairs to 10. One of my favorite ways to do that is using 10 frames and counters. I'm going to use some drawing visual models of those in kindergarten with real students. I wouldn't necessarily be doing visual drawings of them. We would have real 10 frames with real counters, but for now, I think this idea will work. So one of the first things that students need to understand about working with 10 frames is that in these 10 frames, one frame is 10. A complete frame shows me 10. If I have a frame that is completely filled in with counters, that I have 10 counters. And this idea is something that we can help students build when they see that full frame, whether it's a full frame of all one color, we have all the red sides showing across all of it, or whether it's a frame where we have one color and then a second color kind of fills that in. Either way, that when we have a full frame, that is 10. Sort of visually seeing that full frame equals 10. It's a really important sort of milestone to get to in understanding these pairs to 10 using a 10 frame, is that a full frame is 10. Another really important understanding is that when students see just one row filled in on that 10 frame, kind of like this, that's 5. So we have 5 in the top row, we have 5 in the bottom row. That also sort of sneaks in the idea that 5 and 5 is 10. That's one of our pairs to 10. So those are two really important things to help students understand in using this tool and using the 10 frame, is that a full frame is 10 and that each row has 5. And then once we have that, sort of those, it will be much easier for students to sort of count. It gives them a leg up so that they're not always counting everything one to one. And so to have students start exploring those pairs to 10, we might show or give a 10 frame that is partially filled. We'll say, hey, here we have a 10 frame with 8 counters in it. How many more counters do I need to make 10? And having this visual aid for this helps students see that, well, you know what, there's 2 that aren't filled in, and I know that if it is full, we have 10. If there's 2 that weren't filled in, if I filled those spaces in, 2 more, I would have 10. That 8 and 2 must make 10. So that tells me that 8 plus 2 is 10. That's one of those pairs to 10. I could show them an example and not tell them how many are there, and ask them to count. Hey, what do we have in this 10 frame? How many more do we need to fill in the 10 frame? And then what equation could we write to show that? So students could count, well, here we have 5. If I know that my top row is 5 and 6, so I'm starting with 6, and then how many more do I need? Well, I can see I have 4 gaps. If students don't see that right away, they can use their counters on the other side and fill it in and count 1, 2, 3, 4. So if I add 4, 6 plus 4 is 10. This is also a really great opportunity to start sneaking in the commutative property. And though in kindergarten we don't have to name the commutative property, we can certainly start engaging with and exploring the idea of the commutative property. So after we show an example where students figure out that 8 and 2 more gives us 10, maybe we give them a 10 frame with only 2 and ask, how many more do we need to fill in our 10 frame? And so students can add their 5, and I'm starting with the bottom because I know I can count the bottom as 5. I know there's 5 in the bottom. You don't have to start that way, but there we go. We have 5, and then 6, 7, 8. So if I start with 2, and then I add 8, I get 10. And we don't even have to point this out directly to students that these same add-ins gave me 10, these same add-ins gave me 10. Eventually they will start to see that pattern on their own. It allows them to sort of discover the idea of the commutative property. They might almost feel like they're inventing this idea. They've happened upon and discovered some really cool mathematical idea. We do the same thing like with 6 plus 4. We can show them, hey, if we started with a 10 frame that had 4, how many do I need to fill this in? And again, as students use these 10 frames and use these counters, they will get more efficient. They might immediately look and see, well, I have a whole row as 5, and then one more makes 6, because I can go 5, count one more, that gives me 6. If they can't think of it that quickly, they can use their counters and fill them in. 1, 2, 3, 4, 5, and 6. So I know that 4 plus that 6 gives me 10. Using that 10 frame to really reinforce that idea of those pairs of 10. And we don't have to rush this process. We can take all year with this process if we need to. Again, in kindergarten, the addition and subtraction benchmarks are limited within 10. So students are adding and subtracting numbers within 10, and then we have that specific benchmark that matches this, understanding those pairs of numbers to 10. If students leave kindergarten sort of fluent with those pairs that make 10, it's going to make the work in first grade, second grade, and so on that much easier.